Hi everyone, in today's video we are going to discuss how to identify the components and their functions installed in the solar power plant. Objectives: at the end of this video you will be able to number 1. Visit and interpret the details of the solar power plant. Number 2. Trace and identify the components used in solar plants and write down their functions. Number 3. Prepare and draw the schematic diagram of the solar power plant. Note: trainees may visit the nearest solar power plant to visit the various equipments of the power station and learn the functions of each equipment from the plant engineer. Before entering the power station, the trainees should be aware of the safety rules and regulations prescribed for the plant areas, like wearing personal protective equipment, not touching any power lines or solar panels, etc. First, let us discuss solar energy. One of the main renewable energy sources is the sun. Sunlight and heat are captured and transformed into several types of energy. Solar energy is a technique that converts sunlight into electrical energy either through photovoltaic cells called solar panels. What is meant by photovoltaic cell? A photovoltaic cell, commonly called a solar cell, is a non-mechanical device that converts sunlight directly into electricity. Silicon is the most common semiconductor material used in solar cells, representing approximately 95% of the modules sold today. A semiconductor substance is used in a photovoltaic cell to capture photons released by the sun and convert them into an electron flow. Elementary particles known as photons travel at a speed of 3 lakh km per second when carrying solar radiation. When the photons strike a semiconductor material on the p-n junction, the junction breaks down and electrons start to come out and then to the load. The amount of power generated from the solar panel depends on the amount of sunlight that falls on the solar cell. Step 1. Visit the solar plant and note the details of the plant. Number 1. Capacity of the plant 648 megawatts. Number 2. Output voltage 400 kilovolt. Number 3. Permitted maximum load circuit 1500 amperes. Step 2. Trace and locate the components used in that solar plant. Total solar panel area 2500 acres. Method of mounting panels. The best solar panel performance occurs under direct sunshine exposure. Modules are positioned at an angle facing the south for that to happen. Ground-mounted solar power plants function similarly to rooftop solar systems. This includes absorbing the sunlight to generate an electric charge and then transferring it to the inverter through conductive wires. In ground-mounted panels, the structure is carefully selected with a tilt angle and orientation to maximize sunlight exposure. Controller circuits. The silicon and the conductor in the panel convert the sunlight into DC, which flows into the inverter. The inverter then converts DC to AC since the power requirements are in AC. A module cannot be connected directly to a battery, so a charge controller and an on-charge regulator is used in between module, battery and inverter are required to operate AC appliances. So, the whole system except the module is known as the balance of the system. MPPT controller is one of the main components. As the maximum power operating point is drifting depends on climate, which is unpredictable in short time scale, this controller keeps the solar panels working in the highest energy efficiency ratio. Battery system installed. A battery used in a solar system to store the excess electricity generated by solar panels. Solar panels can be connected directly to the load, but the solar may not be constant, high during the day and low at night. So the high power generated during the day is stored in batteries and may be used during the night. You can then use that stored energy at times when your solar panels don't generate enough electricity, including nights, cloudy days, and during power outages. Solar panel companies prefer lithium-ion batteries because they can store more energy, hold that energy longer than other batteries, and have a higher depth of discharge. DC/AC inverter capacity. Solar panels generate DC, whereas households and industries primarily consume AC. Thus, inverters convert solar energy into a form that is usable by customers. There are two main types of inverters: string inverters and micro inverters. In a large-scale utility plant or mid-scale community solar project, every solar panel might be attached to a single central inverter. String inverters connect a set of panels, a string, to one inverter. That inverter converts the power produced by the entire string to AC. Although cost-effective, this setup results in reduced power production on the string if any individual panel experiences issues such as shading. Microinverters are smaller inverters placed on every panel. With a microinverter, shading or damage to one panel will not affect the power that can be drawn from others, but microinverters can be more expensive. Distribution panel to grid connections. The grid power is in the form of AC, and if we need to supply power to the grid, we need the output of solar plants to be similar to the power of the grid. In this system, the most important condition is that the output frequency and voltage must be matched with the grid's frequency and voltage. And also, the power quality maintains the grid standard. Step 3. Note down the daily average power output of the plant for distribution. Step 4. Note specification of solar panels, make voltage ratings, etc. Wattage of each solar panel: 100 watts. Output voltage: 12 volt DC. Maximum output current: 9 amperes DC. Maximum operating temperature: 180 degrees Fahrenheit. Type: polycrystalline. Make. Step 5. Note tracking system method provided for maximum output. Step 6. Note protection of cells from natural calamities. Step 7. Note installed cells whether in ground level or elevated. Step 8. Draw the schematic diagram of solar power plant as per the guidance.
Recap. Discussed how to trace and identify the equipment used in solar plants and their functions, as well as how to prepare and draw the schematic diagram of the solar power plant. Thank you and have a great day.